Today's notes are on gas variables. Throughout this unit, there will be 4 variables that we will be discussing with gases. The first one is temperature. And when we're talking about temperature in equations, we represent it by a capital T. The definition of temperature is a measure of kinetic energy. And as we discussed in thermochem, kinetic energy is the energy of movement. So really what temperature means, it's talking about the speed of the gas particles. So if the temperature gets higher, that means that the gas particles are moving faster. If the temperature gets lower, the gas particles are moving slower. And there's 2 units that we use to measure temperature. Those are degrees Celsius and Kelvin. Most of the time, we're going to be using Kelvin for our different calculations later on in the unit. But sometimes in the problems, we're given the information in degrees Celsius, so we need to be able to convert between the 2. So to do that, we use the equation degrees Celsius plus 273 is equal to Kelvin. Notice that there's no degree sign when we're talking about Kelvin. It's just a capital K. And in problems, sometimes you will see something that says that the gas is at standard temperature. What that means is that the temperature of the gas is at 0 degrees Celsius or 273 Kelvin. Also, there's going to be times when you're asked to draw out a situation. So how do we represent temperature in our pictures? Well, if this is a sample of gas, we put on each particle of gas that we're talking about, we put an arrow. The length of the arrow indicates the temperature. Now, because gas particles move randomly, the arrows point in random directions. Within a single sample of a gas, the arrows should all be the same size. So in that picture above, we have relatively low temperature. If we wanted to increase the temperature of that picture, we would show the same gas particles, but with much longer arrows. So this would indicate that the gas is at a high temperature. And as I said before, we try to make the arrows approximately the same size within that box. The next variable is volume. And when we're talking about volume, we represent it with a capital V in equations. The definition of volume is the amount of space an object occupies. But with gases, what that really means is that it's talking about the size of the container. Because remember in the kinetic molecular theory that the size of the container is the volume of the gas because the gas particles themselves occupy insignificant volume when compared to the space between them. The units we use for volume are milliliters, liters, and centimeters cubed. Things to note, 1 centimeter cubed is equal to 1 milliliter. And also to note is that 1,000 milliliters is equal to 1 liter. So this allows us to convert between different volumes and different units of the volume that we need to, so that we can do calculations later on. And we also need to understand Avogadro's law, and that is that the number of particles making up a sample of gas is proportional to the volume of that gas. Basically, what that means is the more gas particles a sample has, the bigger the volume it is, which makes sense. If you think about blowing up a balloon, the more air you put into the balloon, the larger the balloon gets. That's an example of Avogadro's law. Now, just like with temperature, we also have a way to represent volume in pictorial form, and that is as simple as the size of the box that you draw. So a small volume is going to have a small box, whereas a large volume of the gas will have a large box. Now let's move on to the next one, and that is number of particles. number of particles is represented by a lowercase n in equations. And the definition of it is really difficult. It is the number of particles in the gas. The units, however, though, most of the time we're going to be using moles. It can also give you the information in atoms or molecules. And atoms or molecules really just depends on the formula of the gas. So if it is a singular, if the particles are made of singular atoms, then it's going to be talking about atoms, which you can convert to moles. If it's talking about molecules, or if it's talking about something that is molecular, it's going to show up as molecules. And we also have pictures for our number of particles. And the number of particles are just represented by the number of dots. So if we have a small amount of particles, that is not many particles. Or this should be about the same size box. We have lots of particles. Then we have a lot more dots. So this is many particles. Simple enough. And the last one that we have is pressure. And pressure is represented by a capital P in equations. The definition, there's really two definitions for pressure. The first one is force per unit area, and that's a physics definition. So really, that just says pressure is equal to force, and because per means divide, force divided by area. So if you think of a nail, and I mean like the construction type of nail, and somebody stepping on that nail, big old cartoon foot, that's going to hurt. Why? Because it has a very small area and a large amount of force. However, if you take a bed of nails, you increase the area, and you can take that same force, that same person laying down on that bed of nails, and it's not going to hurt them very much. Those nails will not puncture their skin because you've increased the area, which means you've decreased that pressure. The other definition of pressure is the gas law's definition, and it's important that we understand this as well, because this is the one that we're going to be dealing with most often, and that is the force of the particles colliding with the sides of the container. So again, a gas definition of pressure is the force of the particles colliding with the sides of the container. So as particles are moving, they're hitting the sides of the container. That creates a force. But it also means that the area that we're talking about is the surface area of the inside of the container. And the units for pressure we have a lot of them. They're torrs, millimeters mercury, pounds per square inch, also abbreviated PSI. This is the unit of pressure that you're probably familiar with if you've ever inflated a bike tire or a car tire. ATMs and kilopascals. And just like when we had standard temperature, we also have a standard pressure. So that's 1 ATM, which is equal to 101.3 kilopascals, which equals 760 torrs, which equals 760 millimeters mercury, which equals 14.6 pounds per square inch, or PSI. Notice that torrs and millimeters mercury have the same number. What that means is that torrs and millimeters mercury are essentially the same unit. They're just called different things for historical reasons. Now, we also have pictures for pressure as well. So all we do for pressure is, if we have a box that contains some gas, all we're doing is we write a letter P on the side of it. So if it's a little p, then it's low pressure. versus a very large P will be high pressure. And that concludes our information on the 4 different gas variables. Good luck with your worksheets, and if you have any questions, please ask. Thank you.